See, in second year we will be having totally almost 17 chapters, 17 topics. In first year we will be having 16 topics. So let us start the first chapter in second year physics intermediate, that is sound waves or wave motion. Okay. In this chapter, in MSET you will be getting almost 3 plus 1 marks or 4 marks, whereas in UGC undergraduate NEET exam you will be getting around 18 to 20 marks. Okay. Now let us see what is meant by sound. See, sound is form of an energy. How sound is produced actually? To produce sound, a medium is required. The medium is nothing but solid, liquid or gaseous state. And because we know solids have atoms and molecules bound together, therefore the sound velocity is more in solids, less in liquids and least in gases. The velocity of sound will be more in solids, less in liquids and least in gases. Okay? Right. Now first of all, how can you produce sound? In laboratory physics lab, sound is produced by using a tuning fork. You can see this is a tuning fork. Okay? These two are called as prongs. These two are called as prongs and this is called as stem. So when you take a rubber hammer and excite these prongs, the prongs gets excited and they move to and fro. They move to and fro. You can see. And the air molecules during this process are compressed and rarefaction. Compressions, rarefactions. Compressions, rarefactions. Compressions, rarefactions. So like this, the sound waves will be reaching the eardrum of the human being. Eardrum of the human being. Okay? When we draw a graph for this one, time versus displacement of the particles, then you can see the graph will be in this fashion. This graph is the displacement of the particles, time versus displacement of the particles. Okay? Right. Now, what are the requirements to produce sound? First of all, to produce sound, the medium is required, as I said you. Sound cannot travel through vacuum because in vacuum there is no air molecules. Okay? So first of all, sound, to travel sound, medium is required, solid, liquid, gases. Velocity of sound is more in solids, less in liquids and least in gases. Okay? Right. Now, the sound produced by any source, is it audible to the human being? There is a range of the sound. For example, for human beings, the sound range is, frequency range is around 20 hertz to 20,000 hertz. This is the frequency range for human beings. Okay? So therefore it is called as audible range. It is called as audible range of frequency. So if the frequency of the sound produced in the air is between 20 hertz to 20,000 hertz, then it is called as audible range. And if it is less than audible range, if it is less than 20 hertz 20,000, it is called as infrasonic sound waves. Infrasonic sound waves. That means if the frequency produced in the air is less than audible range, then it is said to be infra. For example, best example for this one is nothing but the earthquakes. The example for this one is earthquakes. Because whenever earthquakes are coming, we don't know, because we cannot expect the earthquakes that tomorrow it will be coming or today will be coming or yesterday it has come, because we cannot detect, because this is less than our audible range. It comes under infrasonic sound waves. Now, if the frequency of sound is more than audible range, then it is called as ultrasonic sounds. Ultrasonic sounds. That means if the frequency of the observer, whatever the source of sound is producing, if it is more than this audible range, 20 Hz, 20,000, then that frequency is said to be ultrasonic sounds. This you can say, take so many examples like animals. Best examples are animals. In animals, the first one comes under bats. Bats. So bats can hear up to 100,000 Hz. That means 1 lakh Hz. That is when in the night time they will be traveling long distance by producing some sound, ultrasonic sounds. Same way, if you take dogs, dogs can hear up to 40,000 Hz. The same way cats can hear up to 30,000 Hz. Okay? And like that, if you take so many examples, like that tortoise around 50,000 Hz. Okay, this is tortoise. Tortoise can hear up to 50,000. These are some range of frequency for different animals. Okay. Now let us see the next concept in this sound waves. Now, as I said before, sound cannot travel through vacuum because the molecules of air is required, medium is required, like solid, liquid or gaseous state, and also sound is more in solids, less in liquids and least in gases. Now, what are the different modes of traveling sound waves? Generally, as I said just now, sound waves in the air are longitudinal progressive waves. Longitudinal progressive wave. Now, what is the equation of progressive wave? What is the equation of progressive wave? In general, the equation is taken as y is equal to a sine, either you can write omega t minus kx or kx minus omega t, anyway you can write. This equation indicates that the wave is along x direction. If the function is x, it is in x direction. If the function is in y, it will be in y direction. If it is in z, it will be in z direction. And here the parameters you can see, a is called as amplitude and it is a sine function. Omega is called as angular frequency, t time, and k is wave number or constant, propagation constant, and x is called as path difference. And make a note, this equation can be even in the form of cosine function, not only in sine function, it will be in cosine function also. It can be in cosine function. Okay? Now one more important thing regarding equation is, if both are same sign, for example, y is equal to a sine omega t plus kx or kx plus omega t, or y is equal to a sine minus omega t minus kx. If both are in negative sign or positive sign, the wave is propagating along negative x direction because x is the function. If y is the function, it will be going in negative y direction. If z is the function, the wave will be going in negative z direction. Okay, this one you have to make a note. If both are same sign, either plus or minus, the wave will be in negative x direction of the function x or y or z, x direction or y direction or z direction. If one is plus, another is negative, then it will be along the positive direction of the axis, either it may be x or y or z. Okay, right. Now we will write different equations in the sine function or cos function. This equation can be also written in cos function also. Y is equal to a cos omega t minus kx or plus x, minus or plus. Okay. If cos is given, you can convert into sine, say like this. Because from trigonometry, you know what is cos theta. Cos theta can be written as, you can write sine 90 plus theta or sine pi by 2 plus theta, because you know in trigonometry in 4 quadrants, first quadrant, second quadrant, third quadrant and fourth quadrant. In first quadrant all are positive, second one sin theta and cosecant theta are positive, third quadrant tan theta and cot theta are positive, and fourth quadrant cos theta and secant theta are positive. Okay, first quadrant all are positive, all silver teacups. Sin theta and cosecant theta are positive, second quadrant. Third one tan and cot, and fourth quadrant cos and secant theta are positive, remaining all are negative. So like that, if you see sin 90 plus theta, second quadrant, and in second quadrant sin is positive, therefore sin 90 plus theta means cos theta. In the same way, suppose if minus cos theta is given, then you also can write down, see, sin theta minus pi by 2. Sin theta minus pi by 2, what happens? How to get minus? Multiply and divide with minus 1. When you divide and multiply the minus 1, take minus 1 inside. Then what happens? Pi by 2 minus theta. That means sin 90 minus theta again first quadrant. Sin 90 minus is cos theta. And here one more minus is there. So minus cos theta. So you can express in any way by using trigonometric functions. If cos theta is given in term of cos functions, you can convert into sin function. If it is given minus cos theta also, you can write sin theta minus pi by 2. Okay, where pi is in radians. If you are writing in 90, it is degrees. Yeah? Right. Now let us go to the next item in this one, sound waves. So let us summarize what I have learned till now. We have learned what is meant by sound, how sound is traveling. As we know, it requires some medium like solid, liquid, gases. Sound cannot travel through vacuum because there is no molecules. Completely it is vacuum. Okay. And also we discussed about progressive wave equation in the form of sine function and cosine function. Okay. Now let us go to the further chapter in this one. That is how to get the constructive propagation of sound waves and destructive propagation of sound waves. Okay. Now let us before going to that concept, let us take a small break now for few minutes.